All right, so now what we're going to do is tie all of this together with this script. I'm going to go ahead and remove this C# script from here and go ahead and say new script. And in this case, we're going to make sure this is GD script. I'm just going to do built-in script right now, but I'll make sure that there is the script saved to the project over here for you. So let's go ahead and say create. Now, since this is on the root, I'm just going to keep this the way it is, but it really doesn't matter what type of node this is, because we're not actually doing anything directly with this root node. Everything's coming from the children. So let's go ahead and we're not going to need the ready function, so let's go ahead and delete that. So the first thing we want to do is get reference to a few things. We are going to get a reference to our CSG polygon 3D. So let's go ahead and do that. And as I said before, I already wrote this in C# previously, so don't feel intimidated when you see this code just kind of come together. It usually takes several iterations if you're writing something like this from scratch. So let's go ahead and get our path node. And let's go ahead and grab our start point. So these three, this is the mesh that gets extruded along the path. This is the actual path, and in this case the start point is our pseudo character, if you will. And let's go ahead and add an endpoint also. Now we're not getting a reference to this endpoint through the inspector. And the reason for that is because in this case we have three different goals. We have the red, green, and blue goals, and we are going to be getting those dynamically. So there's no reason to grab a reference in the inspector for those. So we're going to get the path width equals, and this is a variable that we can change to change how wide the path looks when we actually draw it, so we'll be doing that dynamically as well. And we're going to do the same thing for the height. I'm not sure if you would necessarily want to set this, but perhaps, so that's why I'm including this. This is just how thick vertically this path is. Most likely you want it to be as thin as possible. And these will be our path colors. You wouldn't necessarily want to do it this way if you were to make this system within your game. We're just adding them this way for ease of use. You might want to just do it a different way, whatever works best for your own needs. And now goal will be the numeric index of which goal we currently have selected. So if we hit 1, it'll go to the red goal. If we hit 2, it's going to go to the green goal. 3, the blue goal. All right, and for the goal selection, we're going to have an animation wait, and what this will be for is we're going to actually animate the path widening, just so that we have something interesting going on when the path is changed, and that way it just doesn't look like it just suddenly appeared in a different, or appeared going to a different goal. And we'll have the animation speed, and we do want to export this one because you might want to tinker with this value a little bit, and that was obviously a typo. And now I think that is all of our variables. So what we can do is we can go ahead and start assigning these. So the CSG mesh is this polygon 3D, and then we want our path. Our start point is, again, is our little guy that we had set up. Path width, we'll just keep these as the defaults, and we want these path colors to match what we have in the for our goals. So let's go ahead and set that one to red, whoops, green, and blue. And we'll just leave the animation speed there for now. And now what we're going to do is every frame we want to check if the user pressed a different key. So to do this, we'll write a for loop. And you would want to put a value in this for loop from 0 to whatever value you want to use. So it could be 3. We could really just do 10 for all of the keys. And now we want to just say if no key was pressed with this current index, we just want to continue to the next value for I. So we're going to say if not input dot is key pressed key 0 plus I, and then just say continue. And the reason for that, of course, is because if they didn't press anything related to that number, there's no point in checking the rest. Now we want to do if goal is equal to I, continue. Because what that means is there was no change. For instance, if they pressed 1 and then they pressed 1 again, or they pressed 2 and then they pressed 2 again, the first time they pressed it, we want to do something with that input. The second time it was already set to that number, so we don't want to do anything with that input. And now let's say if get node goal plus string of I. Oh, whoops. Equals null. Continue. So if there is no goal that matches the number of the key they pressed, then we're going to continue there also. And then finally, that means that it does exist, and we'll say goal equals I. And we want to reset this animation weight. This animation weight will increase this from 0 to 1. 1 being the path has fully widened, and 0 meaning the path has not widened at all. So we want to reset that to 0. And you saw me just get rid of pass. You can get rid of pass. It is only there as a placeholder for any function in GDScript so that you can actually have some code in there if you wanted to make like a skeleton of your code, let's say. All right, and now we want to say if the endpoint is null, we want to return. And of course the reason for that is if there is no endpoint, we do not want to oh actually, whoop. I was kind of wondering, I had never assigned that, so I was looking at that, and if that's null and we return, then this code is all useless. So we actually need to grab the node here. Get node and goal plus string goal. So now, if the endpoint is null, we return. And the main reason for this is before the user ever hits a key here, the endpoint will be null. So we just want to return. After they've pressed a key that matches in actual goal the first time, then this should never be null after that. So this really only guards against the initial case where the endpoint is null. Okay, and now this is where it gets a bit more interesting. So currently how Godot handles 3D navigation is in the navigation server 3D, it has a list of navigation maps. So we need to go through the resource IDs of each of the maps and then grab the path from that map, and then we can use that path if indeed it returned a list of points for us. So how this works is we're going to say for RID, which is a resource ID, in navigation server 3D dot get maps. And now we will say path equals navigation server 3D dot map get path. And then we're going to pass in the resource ID. And now we're going to pass in our start point and its position, and then the end point and its position. Whoops. And then we want to pass true for optimize. And so let me try and get this a little bit. so you can see everything a little bit better. Okay, so what this is doing basically is for the navigation map that we have, if you remember, we baked that for this region 3D here. So what this is doing is this is grabbing the map for this navigation region that was baked, and then we are giving it a start point and an end point, and it will give us a path, a list of points as the return value. So now what we want to do is we want to check and make sure that we got at least one point for this path, or actually at least a couple of points, but the path should not be 0. That's really the main point. Now what we want to do is take these points, if we got a list of points, and we want to create a curve out of it. So let's go ahead and grab our curve from our path node and say curve.clear points. So that will get rid of all the points in that curve. And one thing that we also want to do is, so this path that it gives us might have a few points that are really scrunched up together. So what we're going to do is we're going to create a corrected point array. So let's go ahead and create a corrected path, and then we'll say corrected path dot append. So we definitely want the first point that was returned in the path. And now, so what we want to do is we want to go through each of the points in this path. And since we already have the first point, we can just start at index 1. So we can say path.size, and we want to just go 1 shy of this. Actually, you know what? Let me back up. We actually do want to start at index 0 here. And the reason why is because we're going to compare the 0 index of the path against the next point that we're looking to add to our corrected path. So we want to go from 0 to 1 minus the path size. So if we go ahead and put our if statement here, so we're going to put if the distance, oh, whoops, forgot the colon there. Was wondering why the autocomplete wasn't working, and it still isn't working. That's fine. So we want to get the distance squared to path I plus 1. Okay, so let's do that. Still have an error here. Let me see what might be the issue here. Oh, of course, because we didn't put our condition yet. Okay, so yeah, still having an issue. Well, I will come back to that line here shortly and just see if I can see what is wrong with that. Maybe it's that I don't have the statement underneath it. Oh, there we go. Whoops. Okay. So what we're doing here is we are checking the path index 0, and if at first path index 0, and then 1, 2, 3, all the way up to size -1. Actually, size -1, because it does not go to the very last value. It goes to the last value of -1. So what we're going to do here is we're just checking if the first point is less than this small value to the second point using distance squared. This is just a much faster way to check distance. And then if that's true, then we're just going to skip that point, and then we'll move on to the next point. So now we're going to say corrected path dot append path I plus 1. So if this value, or if the distance between point 1 and point 2, or point 2 and point 3, etc., is not a very small value, then we'll go ahead and add it to the path. And so that will take care of the whole corrected path. And this algorithm right here is not perfect by any means. You might need to do something better for your game. This is just to make it so it doesn't look ugly by having scrunched points together. But this is definitely not perfect by any means. So, but it should get the job done in this case. Okay, so now we have our path. So now what we want to do is we want to go ahead and add these points to our curve. Okay, so let's go ahead and do for I in range, and we'll do 0 to the path size, and if it's not the first point, and let's see, and if I is less than path dot size -1. So basically this is what we're doing, is we're checking if the point is not the first point and not the last point. And so then we want to grab a vector between the current point and the point before it. And then we want to grab the next vector, which will be the next point minus the current point. Whoops. And then what we want to do is we want to calculate the tangent of this vector plus the next vector. And then we want to normalize, normalized. And then we want to just half that value. And we'll say curve.add point, and now we will add the actual point and the in tangent and the out tangent. All right, and then otherwise, if it's the first or last point, we just want to add them. And this should help our path to look proper. All right, so now what this should do is that will create our curve for our path node here with a set of points that has been that we've removed points that are too tight together, and then we can go ahead and we will do the animation that I was talking about. So let's do anim weight equals clamp F, so that's for float. And we'll say anim weight plus, so this is the current animation weight, which right now is 0 if we just pressed one of the keys. Or if it went to the next frame, it will have a different animation weight, so, or an increased animation weight. So we can do anim weight times, and some of these numbers you could just play around with them a bit just to see what they'll do. These numbers just seem to look pretty well, so that's why I'm going with these. And 0 to 1. So what this will do is, whoops, this should be on weight here. Okay. So this should be the previous animation weight, which when you first press the button is 0 again, plus the current animation weight times 0.2. So we're just taking just a little bit of the current animation weight, and then we're adding the delta times the animation speed. So by default we have animation speed set to 1, and then of course the delta is the number of seconds since the last frame. So this should be, maybe like 0.03 or something like that if you're going, or 0.033 if you're at 30 frames per second or 0.016, etc. if you're on 60 frames per second, or whatever the frame rate might be. That delta would give you the time since the last frame. Alright, so now what we want to do is we want to update our CSG mesh with our animation weight value and our width value. And we're going to do that by creating a new function. And what I like to do is I like to use the smooth step function. What this does is kind of gives it an ease in and ease out for the animation. You really could just plug in, you could just put like the animation weight, let's say, in here if you wanted to. And it would animate for you, but smooth step will give it a nice ease in, ease out again. So let's go ahead and create that function, and it's called make line. We want to pass in weight, which is a float, and it will return an array of type vector2 because it's a line. Let's see. So this will be the actual line that we're going to output. And we want to initialize it as empty. Oh, forgot the colon again. And don't worry about that error. We are going to return the value eventually. So we are going to get a width for our line. So now we will say W, this will be width. You could name it width if you wanted to, but it's just, we're going to use this variable multiple times, so whoops, okay, whoops, alright, equals path width weight. Okay, so the weight is what we passed in. The path width, now we want it to be half of the path width, because half of the path width is going to go positive x and the other half will go negative x, and so from negative x to positive x will be the path width. So that's why we need to multiply it by 0.5. Half of it will go to the left, half of it will go to the right, essentially. If you were to talk about it in 2D terms. So now we want to say line dot append, and we're going to create a vector2 with negative width, negative path height. If you remember that variable from much earlier, actually we're going to be essentially using the same thing but just modifying the sign with it. So these ones will be positive. If you can imagine, what we're actually making here is a square. So this would be like bottom left point. This one would be top left, top right. bottom right. And now we're going to return our line. And now that resolves that error. All right, and finally, what we want to do is set nav line color, and this will be another function that we create. So let's go ahead and actually, you know what? Just copy and paste, much easier. And for this, we'll just say I. That's our index. And now if path colors, we want to guard against the path colors being null, just in case. And we also want to make sure that the size of the colors is greater than or equal to I. Actually, I might be a little bit misleading, but we're going to go with it. And the reason why is because it's not actually a zero-based index. I will be like 1, 2, 3, where 1 would be the zero index. So, and now what we're going to do is we are going to create one more function just to maybe make our lives a little easier. And we'll say func get line material, and we're going to return a standard material 3D, and it'll be the CSG mesh dot material as a standard material 3D. Oops. And we need to actually return that. All right, so get line material. And we're going to set the emission to the path color. And again, like I said, the I is not actually an index, so we need to subtract 1 from it. And with that said, I think that's it for the code. Let's go ahead and try and test this. And so I'll run it with F6. And let's see if this actually works. Nope. Oh, right, because we do not have a material on our polygon. So let's go over here, and it'll just be this material right here. New standard material 3D. And for that, we want to get the right look, we want to get rid of the albedo, and we want to turn on the emission, and I think that is it. Let's go ahead and hit F6 again to run it, and there you go. I'm pressing 1, 2, and 3. And let's go ahead and say always on top for that, and go remote and see if we can move some of these goals around. Yeah, there we go. And you can see it actually changing in real time. And that's because we, of course, put it in that process function. If you don't think that your goals or your player are going to be able to move, while this navigation line is showing. You probably don't need it in the process function. You don't need it to read that path every frame. That's probably inefficient. But if it's a game like Arkham Knight, where you're in the Batmobile and you're driving along the path to a goal, that goal might be moving, and obviously you're moving, so you would probably need to calculate that path. Maybe not every frame, but you would need to calculate that path fairly often. But perhaps in a game more like Dead Space, where the goal is not necessarily moving. I don't remember if there are any goals that move in that game, but let's just assume for argument's sake there aren't. Isaac stands still, and if the goal's not moving, you really just need to calculate that path one time. Each time the player switches which goal that path is going to be drawn to. So just a bit of advice on that. If you want it to be more efficient, you might need to change what you're doing per the particular scenario that you're using it for. So anyway, I hope that this course has helped you, and hope you have a great day. Bye.